And before I get started, I would like to thank my co-authors, Professor Mike Jenkins and Justin Runyon. It's my turn to struggle with this. Okay, so as a review, monoterpenes are a class of terpenes consisting of two isoprene. I am kidding. I did not. It's not forward. Next. One more. So I know a couple people are disappointed when I said I wasn't going to talk about isoprene units out there, but for everyone else, this is what you need to know about terpenes. They are a volatile organic compound like pinene that are emitted from most plants and a lot from pine trees. They make pine trees smell like pine. They're very useful to humans. They are related to plant defenses. They're an indicator of stress, and they also are related to flammability. So before I go on too far, I'm going to talk about what I call the myth of the Great Basin Bristlecone pine. I've talked to lots of people who've told me they've seen these trees. They're the oldest trees in the world. As a matter of fact, Nevada even voted to have them on their coin. They're iconic. So what Nevada wants you to think about when you think of Nevada is a bristlecone pine, not Las Vegas. But because of this, I think a lot of people start thinking of them only in this state. I've had people ask me if they occur as young trees too. So they're not just this park state. As a matter of fact, in the top left, this is also a bristlecone forest where they occur in a community with other conifers and a much different fuels arrangement. And this bottom right is also bristlecone, where there is mountain mahogany and pinyon juniper with them. So when I was putting this together, I have a whole dissertation of things I want to share with you, where I looked at fuels across environmental gradients and fire and regeneration within disturbances. But since I'm in the rapid fire section, I only got a couple minutes, so I've addressed one question, and it's the physical process of how do tree terpenes change with temperature. And I did this by looking at environmental gradients. So I had two transects where I went to their lower tree line, upper tree line, and halfway in between, and collected some environmental variables like temperature, humidity, heat index, which is a site index that relates to the potential radiation at that site. And my transects were at the northern extent, more or less, of the Great Basin Bristlecone pine and their southern extent near Ely and Las Vegas. And we collected terpenes through June, July, and August at 3 different times during the day at 10, noon, and 2. These are the warmest times of the year and warmest times of the day. And we chose this because that's when the most volatiles are emitted from trees. So how do we collect these volatiles? We place Teflon bags over the apical end of a conifer branch, and we suck air with pumps, vacuum pumps, through traps for 30 minutes. And then we do this 3 times a day. At the end of our day, we collect a bunch of needles, which are ground up, and we process these in the lab. And what we get is a whole bunch of chemicals. We consistently identified 42 chemicals throughout the trees, and I know there is a lot going on in this graph, but what I want to point out is that we analyze them, looking at them through our different elevation classes across our different sites, and all the letters are where there was significant differences, and the bold is where we saw trends, where it increased as we decreased in elevation. And we realized that we needed a more clear way to get the big picture of what was going on there. So we turned to multivariate ordination, or non-metric multi-dimensional scaling. And I know those 2 people who were disappointed that I wasn't talking about carbon skeletons and isoprene units are probably excited now, but I am going to break this down for everybody else. This is a data reduction technique where we take all the compounds, and every point represents one sample site of all the compounds, and I reduce it to 2 axes. So basically what you're looking at here is points that are closer together or more similar, Points that are further apart, more dissimilar. And you can see I have my low elevation and mid elevation and high elevation sites in different characters on the screen, and they kind of clump together. And I have my environmental variables overlaid with those arrows, and you can kind of think of that as a trend line or regression through multi-dimensional space. So this is the same ordination, which gives us a little bit better view of the grading across it. So these are the same points without the triangles and squares, and you can see as the humidity is overlaid as contours and the temperature. So as we decrease in humidity, we go across our ordination, increase in temperature. Elevation wasn't significant, and it looks much more random. So what can we conclude from this ordination that I showed you? Well, temperature, humidity, and heat index were statistically correlated with volatile organic compound production, and climate change affects these. And since it's costly for trees to produce chemicals, it might not be the best survival strategy to have to produce more chemicals with heat stress from that. Our within needle terpenes, the ones that were ground up, were correlated to our heat index, the site index, which is the potential direct radiation at the site. And we also looked at the ratios of alpha pining to certain important volatiles, and what we found was as temperature increases, the ratios of alpha pining to these other compounds decreased, and these ratios have been shown to be important to pathogen defenses. So I showed that there is a statistical correlation between the temperature and the volatile output, but why do we care? How does this tree chemistry affect the resiliency of this long-lived tree? Well, like I said, terpenes are an indicator of stress. They're related to plant defense, and terpenes can affect the flammability of the trees. So here's a regression we did of our ratio of alpha pining to D-limonene. So as our temperatures increase, that ratio decreased to the point that it became very close to the ratios we found in limber pine at the same sites, but these limber pines were infested with mountain pine beetle, and there hasn't been mass attack found in bristlecone pine of mountain pine beetle. So reducing this ratio could affect the strength of these defenses in the trees. So we looked at the initial attraction of the volatiles to mountain pine beetle between Great Basin bristlecone pine and limber pine, and it was almost always the beetles went to limber pine. But we found that D-limonene affected this, and when we added D-limonene to bristlecone pine, effectively lowering that ratio, it confused the beetles and reduced the effectiveness of this tree defense. We also did a lot of burn experiments of the foliage under a hood, and using the metrics of flammability, like time to ignition, temperature ignition, and rate of mass loss, we found there's a correlation to several important volatiles, and one of the main ones was osamine. And we found that there was a significant increase of osamine at our mid and lower elevations at one of our sites. So while it is important to understand this process of how temperature affects the volatile output on these foliage of bristlecone pine, I think it's the interaction of this process with other processes like drought stress and fuels arrangement that really is going to give us the information we need to know the future of this iconic tree. So, thank you. Okay.
Think about whether these were different genetically. I mean, your climate change gradient assumes that they're sort of the same, and it's the climate that's causing a difference in something, you know, as opposed to different population levels, different kinds of genetics?
It's possible. I mean, we tried to select, so you're asking how much difference there was between the sites, right?
Well, how much difference is there in the genetics of the trees?
Oh, the individual trees.
Oh, well, among the different sites.
I mean, there wasn't a lot of difference between site. There was a lot of confusion between, that's why we decided to look at it in a multivariate way, is because there was a lot of confusion, and it's a complex interaction of the chemicals. So I think looking at each compound and which ones are important is certainly still important, but we found a lot of variability, and while I didn't mention this, but sometimes the temperature correlation was really strong, the elevation wasn't, and I think that was because sometimes it was warmer at our lower elevation sites than our upper. Sometimes it was the other way around, but the temperature always was correlated. So I think the amount that they put out and the signature, like the actual chemicals that were recorded, was always the same. So, yes.
All right, thanks.
Thanks.